All right. तो मैं आज थोड़ा सा डिफरेंटली कर रहा हूँ.
Okay.
डिफरेंट ये करूँगा कि अब वो आप पे डिपेंड करता है. Either I can show the action of, let's say, Hadamard transform when you go through the oracle, okay, and so forth, and you can then compute the algorithm on your own, right?
Okay.
Or you show the action of all of those, and then we can collectively do or I can do the algorithm.
Okay.
Right? तो I would prefer कि मैं आपको ये वाला करवा दूँ. मतलब Hadamard ट्रांसफॉर्म हो गया, Oracle से गुजरता है, अगर आपकी n qubit state तो क्या होता है, and so forth, right?
Okay.
So yeah.
That sounds fine.
So first is actually ये कैसे show करूँ मैं? That left hand side is equal to the right hand side.
So you take some initial state. Obviously, ket x is our initial, so we take it as all zeros, for example.
Yeah.
And then we apply the Hadamard to that. That gives us.
Let's do that. Okay.
Okay.
So first would be good. So I apply this. This I know is just 1 by square root of 2, 0 plus 1.
Yeah.
Okay. The other I know is 1. Right?
Yeah.
Looking at the shape of this, because it's n times, right? So, and looking at these two results, I can also write this as this. This is single.
Yeah.
Right? And what should I write here then? Minus 1, right?
Yeah.
X multiplied by y. Okay. And then y sum, obviously sum आएगा over y belonging to 0 and 1 only, n नहीं क्योंकि n just 1 है यहाँ पे.
Yeah.
1 qubit की बात हो रही है. और square root of 2.
ठीक है.
ठीक है.
Yeah.
इन दोनों स्टेटमेंट्स को मैं ऐसे लिख सकता हूँ. चेक करके बताएं क्या मतलब अगर मैं इधर 0 पुट करता हूँ, right?
So
what would I get?
So your y0 means that your power is 0, and your power 0 is 1, so you just get ket 0 over root 2.
No, but there is a sum over y.
Yeah, sorry,
as well,
sum.
Right? So this would be minus 1, 0 times 1, 0 times 0 actually, right? Y पे sum हो रहा है तो 0 भी होगा, 1 भी होगा, right? 0, 1 over square root 2 I'm going to take common, plus minus 1 raised to the power 0 times 1, right? This is not a dot product, this is just like numbers multiplying. And then 1. Right?
Okay. So this is obviously assuming that x is 0. So this is for...
What? So this is 0, and because any number raised to the power 0 is just 1, likewise this thing. So I get
So obviously we assume that x is 0, right?
What?
This is for ket 0, right? So
Yeah. This
yeah,
is 0.
okay.
So 0 plus 1. Is that correct? Does that make sense?
Yeah.
Likewise for one case, I get the same thing, minus 1 to 1 times 0, right? 0 plus minus 1, 1 times 1, which is just 1, and this gives me the minus state, which is just 1 over square root of 2, 0 minus 1.
Yeah.
Right?
Yeah.
So okay, shown. So this is something I can write. Okay, good. Okay, I want to show that, right? What should be my next step? Let's expand. So what is this x, by the way?
Our initial state.
Yeah, but if I...
It's a string of...
Yes,
yeah, it's a bit string.
So it's basically string of x1 dot 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 xn.
Yeah.
Right? Which is just means a tensor product, right? Right?
Yeah.
Okay, good. So in what I can do is compute this thing, right? Right? Okay. So how would I go about it?
You just, I guess, kind of distribute the tensor product in a way.
Yeah.
And it's just
So-
basically a Hadamard individually tensor with each of the...
Very good. So this thing right?
Yeah.
Okay. Now I use this result, right? This thing over here. I use that result.
Yeah.
So how would that basically be? Well, this would be, and this is a dummy index, right?
Yeah.
So I can label it any way I like. I'm going to label it y1 and then minus 1 x1 y1 because this was x1, right?
Yes.
And it's x1 here. And then y1 over root 2. And now this thing tensored with
The same, just x2, y2.
yeah.
Yeah.
So the like dot 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 cancelled completely. This would be just yn minus 1 xn yn over root 2 and so forth. Right?
Yep.
Okay. So so now we see that we have n terms like this. So I can just factor those out. This would just be 1 over. Have you done this in class?
Yeah, we have.
You guys have. Okay.
Yeah, we've been through, because when we did the algorithms themselves, though, this was the first step for almost all of them.
Okay.
So we've been through this, yeah.
Okay, then it's a revision. Okay. So this thing over here. Oh, alright. All of these are gonna get tensored. So this will just be y1 dot 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 yn. And then you have minus 1 times minus 1. And all the powers are gonna get added, right? So it's gonna be x1 y1 plus x2 y2 plus right? And this reminds you of a dot in a product, right?
Yeah.
Bitwise
Mhm.
in a product.
Yeah.
So you can write this simply as basically this thing over here as -1 to x dot y, right? And hence you've shown that this is, oh, the other thing, you can all, just like we talked about here,
Yeah, this is just cut y.
let's just get one. So, yeah, we're done with this. Okay.
It still needs the summation term though, right?
Yeah,
It needs the summation term with it though, right?
the summation term, oh, yes. There should be a summation. So you have y1 and all of these y and
Yeah.
right? Where, I mean, the idea that y belongs to this thing means that you run over all possible combinations
Yeah.
of zeros and ones for a given n,
Okay.
right? इस बात का idea है?
Yeah, yeah.
So, I have uploaded the questions, right?
Yeah.
You guys go over question number 2.
The alternative input.
Yeah. So what would be the first step in the alternative input?
I guess just apply this same thing, but now we have our input state x already as all ones.
Yeah. Okay.
So
So now, using this result, by the way, can you compute this? This is just basically n entries here.
yeah.
So can you compute this?
Would the entire thing kind of collapse?
Yeah.
Would the entire thing just collapse into kind of one thing at the end? Because if our input state is just all ones,
Yeah.
then
What did we show right now? What was the result? It was basically this thing, right? H cross n x, which was just x1 till xn,
yeah.
is this equal to sum over y, 0, 1, and is that correct?
Yeah.
Is this
Yes, yes.
yeah? With the one almost
Yeah, we'll do it.
Okay. So now, right? You just have ones here. So how would this shift?
Just a dot product of 1 with y, and
Yeah, and one is basically like a sort of like a vector, right?
yeah.
Basically, you have one, like
So that's just -1 power y.
yeah, yeah. So this thing would become what?
Just y.
Very good. Just y mod.
Yeah.
So this thing would be This, by the way, is known as the Hamming distance.
Okay.
Okay? Hamming distance. Good. So this is going to be your first step in question number 2.
Okay.
Right? Once you start computing it. Right? Okay. Good. Let's now talk about the other one, which is what's this equal to? ये भी किया हुआ है
Yeah, you went over it in class.
फिर तो आप करा दें मुझे
Um, as far as I remember, we just dump the ket minus,
Okay.
or don't really remember what happens after that. It's got result.
अच्छा U of f करता क्या है? What is the U of f? So what does it do?
It gives you your first qubit is
What is the action of your U of f?
so your first qubit will remain the same. Your second qubit is the bitwise addition of your
Good.
2 qubits.
With
The f of x. So
so
y
y.
with f of x.
Very good. Okay, good. So now you have U of f ये तो बताएं ये कैसे शो होता है because once if we can show this thing right then we can just plug that in there.
Yeah.
So how do we show this ये class में किया हुआ है?
You open it up first.
Yeah.
First you open it up.
Okay. It's the operator is linear so I can distribute. Okay, what next?
I guess just apply the UF onto both of those.
Yeah, I've done that. Right.
Hmm.
So what next? ये आप लोगों ने बताना है. It's written on the board, by the way.
Would you do the bitwise addition?
Yeah.
The
So
two
how would I
qubits.
write that?
We would do get x and then 0 bitwise with f of x, and then same for the other one. Same for
But
x.
I mean, just so I can save space, this would just be f of x, right?
Yeah. Uh-huh.
0 plus
Uh-huh.
that.
Yeah.
So I can just remove this and write f of x.
Yep.
Good. So what about the next one? X.
And then 1 with that.
Good. Alright. So now, अब क्या करना है? I want to introduce this factor somehow, right? So what should I do after this step?
It's something to do with the bitwise addition operator, I guess.
Yeah, but how do I do that? Well, मतलब the most basic तरीका क्या होगा इसे आगे इसको आगे लेके चलने का आप लोगों का ख्याल में?
I don't remember actually.
Okay. So case 1 ले लेते हैं हम f of x equals 0, right? मतलब
Yeah.
cases.
Yeah, fair enough. Okay.
So x, this would just be 0
Yeah.
and minus x, and then this thing over here, and this just reduces to
1.
okay. If I take this out, this is just x, right? And I have 1 over square root of 2 and tensored with, sorry, I should not write this here. This is just this, right?
Yeah.
Okay. The other case would be that this is 1. So in that case, case 2 f of x equals 1, this would want, इससे क्या होगा?
It would just be 0 because subtracting
Yeah.
the second x1 would be x0 instead, and then they would
Very good.
become 0.
So 1 over square root of 2 x. Here, what should I write here? 1. And the other one that you said?
x0.
Good. So I subtract out the negative and x, and I get basically negative this thing over here. Right?
Yeah.
And now it's now very clear that this is actually, I can write these two cases in this form, where if you have this even, then you get this.
Yeah.
If you have odd, you get, if you have odd, you get, sorry, if you have f of x equals 1, you get this.
Yeah.
Okay, good. So now I can assume this thing over here. अब मैंने यही शो करना था ना, अब मैं क्या करूं? u of f linear है, right? और इधर अंदर चला जाएगा, है ना?
Yeah.
Okay, so अब क्या रह गया? और ये हमने रिजल्ट कंप्यूट कर लिया है, राइट? तो उसकी जगह पे बस वो सब्स्टिट्यूट कर देंगे, और यही था -1 to the f of x, this thing crosses that, और ये वैसे का वैसे,
ठीक.
make sense?
Yeah.
अब क्वेश्चन 2 आप लोग मुझे सॉल्व कर दो। मतलब कल एग्जाम है, मैं चाह रहा हूँ आप लोग खुद थोड़ी प्रैक्टिस कर लोगे,
Yeah.
तो गुड सीन हो जाएगा। अच्छा एक बात, जब स्टैंडर्ड डॉच जोजा एल्गोरिथम के अंदर आपकी हाउ डिड यू न्यू कि फंक्शन बैलेंस्ड है या फंक्शन कांस्टेंट?
Oh.
You somehow if f of x is equal to f of y.
नहीं, वो तो आप चीज़ बता रही हैं
हाँ,
कि फंक्शन की, मतलब लेट्स से आप एक बॉब है और एक एलिस है, राइट? और लाइक व्हाट वाज, जब आप फाइनल मेजरमेंट करते हो, राइट, तो व्हाट वाज द थिंग दैट टोल्ड यू कि
It was like kind of the number of times you get a result in a way. Yani ke
so
Because I was just trying to basically Google all the concepts. So what I thought was कि like if you make it 0, then it's constant, and if you make it
yes,
100,
precisely, very good. So if you get a string of zeros, right, then it's constant on measurement, and for the other cases you get, so अब वहाँ पे आपने initialize 0 से की थी, अब just by analogy now you know what you're looking for, कि जब आप 1 से अगर initialize कर रहे हो, right, तो आपके पास ये ही ones की string आनी चाहिए, this would imply then
that is constant.
constant.
Okay.
ना मतलब I just wanted to कि आप यहाँ पे जा रहे हो और यहाँ से आपको जाना है, अब आप लोग ये कर लें तो। I'm gonna pause this here और फिर हम लोग मतलब कर लेते हैं।
Okay.
Okay.